Hello friends of the Snap Point Kernel modeling routine. Today we're going to look at a recent measurement I did of uranium-235, highly enriched uranium metal in a stainless steel can. We're going to analyze it with Snap and take a look at doing self-absorption corrections of that uranium metal, also known as a lump correction. So let's open up Snap and take a look. Okay, we're here at the assay calculations page. I've already entered all the modeling parameters for this can. I've highlighted the four primary photo peaks for uranium-235, but before I go into the demo of the self-absorption correction, I will say that I used only the 185 peak without a lump correction and came up with 27 grams. Well, that was somewhat lower than the 40-odd grams of total U-235 they believed was probably in this can. So we come back, and I've selected my four primary peaks you saw earlier in the spectrum. I do a calculative activity, and there's a range of activity here that gets calculated from 4.3 e to the minus 5 to about 6.3 e to the minus 5. So that's not very satisfactory. When I come to my View Curves button, that's going to take us to a visual, and I'm going to expand this and zoom in. And you can see our four photo peaks relative to the average activity. That's what the yellow line represents. Our four photo peaks are showing us a trend that we're underestimating attenuation losses. So I've already gone through this problem, and I selected uranium as my material to do a lump correction with, as opposed to plutonium. I've got 315 microns entered, and we're going to apply the lump correction. And now when we do that, and I'm going to zoom in again, you can see that all four of these photo peaks are giving us an answer that's within 1% plus or minus of the average. Now that's a pretty good lump correction. So as I return and then come to my reports page, we can see that now we're predicting about 41.4 grams, which is much more like what they felt was in the can, and which I believe we can report with confidence. The lump correction, without that, we'd be back at 27 grams, and people would be scratching their heads going, what happened to the rest of our uranium? Well, there you have it. SNAP does it all for us, including those very important lump corrections. I think it's time for you to try SNAP. Give me a call today.